Hi, welcome back to Math 110. I wanted to cover some material from section lesson 3.1 today. I'm going to talk about rates of change. Rates of change you've heard about, I'm sure, in terms of speed, miles per hour, uh, your pay rate, your $30 an hour, $10 an hour, $5 an hour. Rates of change are just how much one quantity changes in relationship to another. Okay. So in terms of speed, it is the rate is how many miles, how far do we go in terms of the time, the change in time. So here 88 miles, we read it as or write it as 88 miles per hour, but it's really 88 miles divided by the time it took to get there. So it took 1 hour. Okay, and this is a per unit. We're going to see this in a minute. Okay. I can express these in different ways, but I want to bring up the fact that they're all going to be equivalent, and they're equivalent if they basically represent the same thing. So before we looked at equivalence when it was conversion factors, when we said 1 foot is equal to 12 inches, they're equivalent. Same thing, it's the same length, but it's just a different unit of measurement. Okay. Also wanted to kind of go through and think about this. If I wanted to say, if I'm going 88 miles in 1 hour, how far could I go in 2 hours? Well, if I multiply this times 2 hours, that hours are basically going to cancel out. So in terms of making money, look at question number 1. It says if you make $100 a day for doing a certain job, how much money would you make in a 5-day work week? Well, obviously we've got $100 a day times 5 days. As long as this is the same units as the unit measure here, it'll be just the $500. The 5 days will cancel out with the $100 per day. So we would like to know, are $100 a day and $500 per 5 day, are they equivalent rates? Is this different? Are we making a different amount of money this way than we are this way? So they describe the same rate in dollars earned each day. So I could say if I multiply the top and the bottom by, and there's 2 ways I could do it. I could scale this up. So if I multiply the top and the bottom by 5 times 100 is the 500 times 5 days, or divide the bottom and the top by 5, that gives me the $100 per 1 day, so I'm scaling down. So as long as I can compare these bottom units are the very same, then I can compare the top to see which, how everything else looks. So write a fraction equivalent to 60 miles in 4 hours that has 2 in the denominator. So if I divide, I want to get 2 here, so what do I need to divide 4 by to get the answer 2? Well, that's just 2, so I want to divide the bottom by 2 and the top by 2, so I need to do the division of the top and the bottom by the same thing, and that gives me 30 miles every 2 hours. And then naturally I could scale this down again, divide it, if I wanted it to a unit per 1 hour, divide the top and bottom by 2, that's 15 miles every hour. So here we want to write a fraction equivalent to $320 in 4 days, every 4 days, that has a 10 in the denominator. So the easiest way to do this is to get this down into a per unit rate. So I'm going to divide the top and the bottom by 4. That gives me the per unit rate. The per unit is the day. That's $80 per day. And then I want to multiply the top and the bottom by 10 so that I'm looking for it being a 10 in the denominator. So that's $800 every 10 days. So I'd like to compare 2 different unit rates, or just 2 different rates. 40 miles in 3 hours, so I've got a cyclist that's traveling that can go 40 miles every 3 hours. A second cyclist can do 50 miles in 4 hours, and I'd like to know which one is faster. So the easiest way to do this is to convert it down to both the same unit rates in the bottom and the denominator. So I'm going to go both of them to the unit rate. I'm going to divide the top and the bottom by the 3. 40 divided by 3 is 13.3 miles per hour. And 50 miles, divide that by 4 to turn this into that unit, and that's 12.5 miles. Once we get these to be the same in the denominator, then we just compare the top. Oh, well, this is 13.3 miles we've covered, so obviously that's faster. So here is, let's say if we had something constant. Now we're going to constant rate, so let's kind of read through this. Most experienced runners get to a point where they can comfortably jog long distances at a consistent pace. This pace, of course, is another way to say rate of change, because speed is the rate at which distance changes compared to time. One particular runner jogs one lap around a 400-meter track in 2 minutes. So these questions assume that the runner can maintain this pace for a long time. So every 2 minutes, I'm going to go 400 meters. The first 2 minutes, I'm going to fill out my table. I went 400 meters. Now I'm going to add another 2 minutes, and then I'm going to add 400 more meters because I've traveled 400 more. And then I keep building up this table, just adding 2, 2, 2, 2, and each time I'm going to add the 400. So the way we looked at this before is if I've got a table here, and if I subtract off the one previous from there, and I keep getting the same value, so in each case I'm going to get a 400. That's a linear. That's a signature of a linear type equation. A straight line if I graph this thing out. So here's the runner's rate, 400 meters every 2 minutes. We want it into a unit rate. So I do a 2, divide the 2 out, divide the 2 out. That's 200 meters per minute. And then I could change things as well. They want us to go to a rate using meters per second instead of meters per minute. So I'm going to use my equivalent conversion factors. I want the minutes to cancel out, and I want seconds to be on the bottom. So I know 1 minute is the same thing as 60 seconds, so these are equivalents. Minutes cancel, and this gets replaced by the second. So 200 divided by 60 is the 3.33 meters per second. And then we can look at, what if we need to find out how far it goes in a certain amount of time? So this is distance per time. So all I'm going to do is multiply the time, and if these units are the same, here's minutes and minutes. Minutes will cancel. 4 times 40 times 200, 8,000 meters. Now what about if I want to do 40 seconds? I can't multiply 40 seconds here and get that to cancel. That would have been a minute. So I need to go back to that equivalent rate in meters per second. We had 3.3 meters per second. 40 seconds. Now the seconds will cancel, and that gives us the 133.2 meters. So here's a general formula for working with distance and speed and time. I like to start out with the other way. I like to say the distance divided by time is equal to the speed. And if I multiply both sides by time, the speed times the time is equal to the distance. So what would this runner's total time be? Now we're going to talk about time for a 10,000 meter race. So here, I want to get this thing, I want to be in time, the results in times in minutes. So 10 kilometers times 1,000 meters is 1 kilometer. So that's 10,000 meters. So here is the rate, the 200 meters per 1 minute, or 1 minute I go 200 meters. So now my meters will cancel out here, and I get 50 minutes. The minutes are on top. So this is the same thing as that conversion factor. 1 minute I travel 200 meters, or 200 meters every 1 minute. Okay. So I hope you found that helpful. I will see you next time. Have a good day.